We can also use log rules to combine simple logarithms into one big complicated logarithm. And that's going to turn out to be the more useful move for this class, simply because we know how to deal with a single logarithm, but not with a whole bunch of logarithms when we're solving equations. So here's an example where we're asked to use log rules to combine. This says use log rules to rewrite this big complicated expression as a single logarithm. When we do this, we're going to use the same pattern as we saw before, namely that negative terms go in the denominator, while positive terms go in the numerator. So I'm doing the reverse process, so I'm going to go in the reverse order. I'm going to work within each term first and use the log of a power rule to push all of the coefficients inside. So this term, I have 2 times the log of x. That's going to be the log of x to the 2. Then I have a minus sign. This term I have 3 times the log of y plus 7. That's going to be the log of y plus 7 to the 3rd. Then I have another minus sign. This term, I have a 3rd times the log of z. That's going to be the log of z to the 1/3. And then I have a plus sign, and I have this term. 4 times the log of x plus 1. That's going to be the log of x plus 1 to the 4th. So that's just the log of a power rule to push the exponents in. And now we're going to combine them. We're going to have one big log, and we do see some subtraction. So it's going to be one big log of one big fraction. So this is positive. We'll have an x squared in the numerator. This is negative. We'll have a y plus 7 to the 3rd in the denominator. This is negative. We'll have a z to the 1/3 in the denominator. And then this is positive. We'll have an x plus 1 to the 5th in the numerator. So negative terms give factors in the denominator. Positive terms give factors in the numerator. And that's all there is to it. Now the one thing to be cautious of is that this only works if all of our logs have the same base. So far we've been kind of ignoring the base. I haven't even been saying the base, right? I've just been saying log, not log base 5 in this problem. And we can do that as long as the bases are all the same. If we have logs in different bases, we can't combine them. So if we have logs in more than one base, our first step is to group the logs in the same base together. So I have a log base 3, and here's another one. I'm going to group those together. And then I have a log base 2, and another one. So I have a minus 5 log base 2 of y, plus 3 log base 2 of x. So what we've just done here is to group the logs by base. Okay, and then we have, well, within each group, I'm going to use the power of a log rule. Next, within each group, I'm going to still push the powers in, right? I'm going to use the log of a power rule. And then in my first group, I'll have the log base 3 of x to the third plus the log base 3 of z to the fourth. In my second group, I'll have a log base 2 of y to the negative 5 plus a log base 2 of x to the third. Notice that that negative coefficient became a negative exponent. Negative exponents give us things that go in the denominator as well. This is not a coincidence. So this first group I can combine. I'm adding these, so I'll multiply. I'll have the log of x to the third times z to the fourth. And then over here, I'm adding these as well. So I could write y to the negative fifth x to the third. Or, if I don't like negative exponents, I could instead rewrite this, leaving the first term alone, and in the second term, write y to the fifth in the denominator instead. So this term did give us something in a denominator, as long as we write it with positive exponents. So that's what we have to do if our logs have different bases. If our logs have different bases, we have to group them by the base. We can only combine logs with the same base. That's a problem, right? If we have logs with different bases that show up, what on earth can we do about it? Answering that question is the last thing we're going to do in this section. And in order to answer that question, we're going to see one more way that we can use our basic log rules.